Hey everyone, we're back. I'm Seth Holler, CEO of Wiser Systems.
I'm Logan Maxwell, wearer of many hats.
And so we've talked previously about process improvement, gone through a bit of terminology, and also talked about automation broadly, but also specifically for real-time location systems. And so today, or this session,
It could be, you might have just watched the other video. So it could be for you 30 seconds ago.
or we might have just taken the previous video. Who knows?
Who knows? We always wear the same shirts.
So we're going to talk a little bit about digital twin and what that means for real-time location systems.
Yes.
So Logan, digital twin, mechanical engineering CAD model.
Yeah.
Not the same thing as a digital twin for manufacturing.
Not. Yeah. It's a bit of a loaded term. I think we've all been at the conferences and all heard a lot of spiels about digital twin and what we're doing. I would boil it down to you are attempting to quantify and digitize the inputs and outputs of a given facility.
Oh yeah. So having more of what's going on in the factory floor copied into the digital world that you have access to through your MES or ERP.
Yes, because it makes it easier to change and improve your processes if you can measure and analyze and model. And in particular, some of the more fancy digital twins are truly software-defined digital twins where you could edit things and see how the flow will change.
Right. So there are software pieces out there that, given the right inputs, they provide information into how well that could improve your process.
Right.
But it depends on the inputs, right?
Yes, and that we could probably talk about for a while, but trash data in equals trash data out. So you have to really trust and know that the numbers you're collecting are good and that you're collecting the right ones in your facility. And some of these facilities that we're in are quite complex of all the inputs that would need to be modeled and mapped to make an accurate digital twin.
Right. For real time, so a lot of manufacturing out there, they don't necessarily track where items are real time. They do have some sort of portal or scanning at different stations, so they do have some limited location data at specific locations. When it gets scanned is sometimes more manual, so you don't know when it got there, but you know at one point in time it was there based on the scan. Real-time location systems, Wiser Systems gives you, like we said before, the analogy is that it's being scanned continuously, no matter what the location. What you get is a timestamp in an XYZ location, and it could be thousands of scans in a single day, or scans, right?
Yeah.
That gives you insight into what?
So think about an item moving through your facility. It's probably different for everybody that's watching this video, but there's a start point, right? And then there's an accumulation point, and then there's going to be some sort of end point. Sometimes there's multiple flows internal to a facility. That's pretty common, right? And so I have, for instance, raw inventory to making my parts turn into kits, my kits turn into full assemblies, right? Some sort of flow or cycle of those parts internally.
So I'm going to use this pencil and paper here. You could have a flow going into circle, right?
Wow. Yes, you could.
But then you could have different subflows going in circles around the main flow, right?
Yes.
And
yes.
That's art for you, right?
That's good. And we'll publish this for those that want it.
Yeah,
we'll put this on there.
It's available online.
It's available online.
And it gets more complicated, obviously, right?
No, and you maybe, as a process engineer, if you're watching this and you're on that side of the fence, you probably already have a flow chart of your facility, maybe, I hope so, of the way that things move internally, right?
Sure.
It becomes very difficult in a complex environment, manufacturing environment, to track the materials through when there's all of these extra loops.
Yeah, I knew that paper
in the process. So we're moving through, right? But occasionally I'm going to have to start one of these loops, right? A lot of it's testing, calibration, rework, right? You might have some sort of flow that's aside the main flow of the process. So what RTLS brings in terms to digital twin is that you're trying to replicate this digitally.
Right.
But what you really don't have usually is accurate location data of all of this holistically.
Right.
You may have a scan here. God, I am going to use this a lot, aren't I? She
Yeah,
knows me too well. So you have a scan here. You might have a scan here. You might have a scan here. You might have a scan here. But you don't have everything. You have to almost think about it as like we're no longer taking estimates and derivatives. Like the whole curve is now available to us. So we drop in, instead of, for all my chemies out there, instead of putting a drop of dye in the water and measuring when it started, when it hit my bubble window, and when it ended, right? So I've got okay, it hit this part of the pipe took a minute. Right. This other part took 5. Okay, that's good data, right? Imagine if you did that with all of your WIP all the time, and your bubble window was the whole thing. You would have all of this information of how it's flowing through each one of these processes to a very granular degree. And that becomes extremely powerful from a digital twin perspective.
Yeah, I guess you could say you have some very limited location data based on periodic scans.
Usually, yeah, you should already somewhat.
But the amount of data that you get with an RTLS system is 100-fold or more.
I mean,
complete awareness. And sometimes when you do these portal scans, because an item was put aside, you may never get a scan. There's no guarantee it will go through one of these portals.
It was scanned last at rework. Yeah. Where is it? Right? But that's a case of go track and find. But in terms of a digital twin context, I now, over the course of days, weeks, months, depends on how long your process is, of how much data you need to gather, but you can start to actually create real median performance metrics of each sort of station, even in a complex flow, recycle, rework, testing, and calibration environment, right?
And you have the available data that
you have people performing all those tasks. Oh, I messed up this weld, I got to re-weld. It becomes incredibly difficult unless you go out with a stopwatch and a camera to understand what a median performance even needs to be, unless you have that sort of data.
Yeah, you definitely have very limited awareness into the path traveled for whatever your kit bag or your part or your whip without RTLS. But once you do and you see all, for example, spaghetti diagrams, you see all the paths that they follow. Spaghetti diagrams aren't useful in and of themselves. They do provide some visual insight, but the patterns that are shown in the spaghetti diagrams, you can start picking out, hey, why did this part go back and forth between these two stations like 5 times? That sounds highly irregular.
Yeah.
Is that a precursor to a larger problem that you probably wouldn't find out about until Joe told you some part was broken in a machine? But these behaviors or patterns can be picked up kind of on a higher level through some sort of pattern matching or larger numerical analysis, machine learning algorithms, for example.
Yep. So you have now lots of, I mean, you said 100x. There's like maybe 100,000x amount more in terms of location data and where things are going. Everything's marked. And so you know exactly when it entered and exited each step, whether or not there was a barcode scan there or not. Like we said, it's constant barcode scanning. So it's just going to constantly be aware of everything. So what I have seen in terms of modeling your facility from a digital twin is digitization of entries and exits and timestamps of how long things have spent on each process.
Sure.
And that's processes are usually determined location-wise, right? That this process happens here, this process happens here, it's around
and you
this
can
machine.
Just put a zone around the station, and once the part goes into it, it triggers, hey, I'm in this station, or once it leaves, hey, I'm out of this station.
Right. And so you can say this hit station 1 here, and then it hit station 2, and then it went back to station 1, then it went back to station 2.
Why did it do that?
Right. And so modeling digital twin is only as good as the information you give it, right? So a standard digital twin in this facility that we just spoke about, yes, it probably got scanned at some point in time of where it is, right? But we're not going to know that it was worked on at this station by this person with this tool, right? RTLS will provide you all of that.
Yes.
Which is quite powerful if you harness it correctly.
Tell me if you like this analogy. Like, for example,
I hate
it. For example, you want a snapshot of facilities, so you might take a camera and take 5 snapshots or pictures throughout the day. And you have to understand what has happened in your facility based on these 5 pictures, right? Now compare that for an RTLS system where instead of like pictures, you are continuously taking a video throughout the whole day.
Right.
And so clearly you gain so much more insight into what's happening within your facility with the video versus just 5 snapshots.
It's a very good analogy, actually. And I'll go further than that. They're not to say that people are going to be nefarious and try to hide things or change things, but there is a lot of times people forget to scan, or people aren't scanning because they're trying to cover up the fact that it's going back and forth to different stations a lot. And so what we find is it's preferable to have a technology solution that's going to be transparent and across the whole organization. Everything is tracked and timing is tracked, right? Other than standing there with a camera. You can get the same data if you know what I mean? Like
manually, you can take a lot of pictures, but it's a lot of time.
You can, and it's even beyond digital twin. This basically digitizes time and motion studies automatically. I mean, you're just constantly taking time and motion studies as opposed to having to go out there and do it. They're just constantly being done.
Right? And notice we're not necessarily talking about one use case. When you do these sorts of things, there are just so many use cases as well. Because of the volume of data. A lot of people do focus on a single use case to get started. You don't have to, but you do have to be very intentional about how you're going to use the system, especially on startup, so that you can realize the goals that you have for the system place. But I digress a little bit.
Yeah. I mean, I'm sure we'll get to that as well, but like, ROI is realized with Wiser. I can't speak to any other RTLSs, but with Wiser, when we leave the site after commissioning, anything you put a tag on, you got that data for. Yeah. Like it's there. It's actively working already. Yeah. And if you're not set up to figure out what to do with that data, I mean, shoot, we've still got shops that are they use it as a track and find, and that's great. But if you're not set up to collect it and understand it, well, you're sitting on a treasure and you're not opening the chest.
Yeah, there are a number of solutions out there where they simply use it for track and find, and kind of the next phase is they look to add more of this intelligence or awareness into the system so they can take advantage of more of the production efficiency goals that they're shooting for. A lot of them, it's evolutionary. Hey, it works in this, and now I'm going to go to the next level. A number of companies do need extra support to realize that as well. We're here to help for that too. But I guess that's another conversation point. So just to summarize, originally we talked about process improvement, went through some of the terminology, and then spoke about this terminology in respect to real-time location systems. And then this time around, we dived into digital twin and the amount of data that you have available.
Yeah.
Any last comments you want to add there?
In summary, RTLS, like Wiser, primarily Wiser, really at this point, is going to provide positioning and timing data that can be used to automate. It can be used in digital twin. A lot of times there's a little overlap of that Venn diagram, but essentially it's providing real, accurate data to your facility. Certainly use it to go track and find. Make sure your expediters can go run and get their stuff. That already honestly probably pays for the system, but you have a lot of data to play into automating and digital twinning your facility, right? And so it's important that it's kind of a new way to think about it. Like you were saying, instead of 5 snapshots, you got the whole picture. So it's exciting, but it's
the whole video.
Yeah, it's you got the whole video. Yeah. So time and position, bunch of data, use it.
Thank you guys. We'll see you again later.